Hi everyone, in this video we are going to talk about the angular acceleration or alpha. Alpha is also a Latin letter we use to represent the angular acceleration. But before we start, let's remember the equation of the linear acceleration. A equals v final, which is the final velocity, minus v initial, which is the initial velocity, divided by delta t. The measuring unit for this is meter per second squared. The average angular acceleration is equal to a very similar equation. It's the change in angular velocity, so alpha is the change of angular velocity omega final minus omega initial divided by the time. The measuring unit for angular acceleration is rad per second squared. The tangential acceleration equals alpha r. So what's tangential acceleration, and what is the difference between the tangential acceleration and the centripetal acceleration and the net acceleration? Let's see. An object is moving in a circular motion. There is a different type of accelerations that you need to be familiar with. If the object has any kind of speed, or if it's moving around the circle, it's going to have a centripetal acceleration. So we have a centripetal acceleration. The centripetal acceleration points towards the center of the circle. The centripetal acceleration is equal to the linear speed squared divided by the radius. And we know that the linear speed equals omega r. In this case, the centripetal acceleration equals omega r squared divided by r, which is omega squared r squared divided by r. And so we can cancel r with the squared, because omega squared times r squared, which is r times r, this is divided by. So the centripetal acceleration equals omega squared r. So if an object is moving with constant speed around the circle, the only acceleration it has is the centripetal acceleration, also known as the radial acceleration. So the net acceleration of the object will equal to the AC, or the centripetal acceleration. So in this case, the net acceleration equals AC, and it pointed toward the center of the, cancel this one. What if it's accelerating around the circle? So then it's going to have a tangential acceleration, A tangential. And the tangential acceleration equals the angular acceleration times r. And we also found the tangential acceleration using this equation. It's the change in velocity divided by the change in time. Now notice that these two vectors are perpendicular to each other, because the tangent is perpendicular to the radius. So if you have the centripetal acceleration going this way and the tangential acceleration going that way, so the net force is the vector sum of these two accelerations. It will be this way. So this is the centripetal acceleration, and this is the tangential acceleration, and this is the vector sum of them, which is net. So the vector sum is going to be the square root of the hypotenuse, which is AC squared plus AT squared. So if we are going to revise all the equations we talk in this section, so this is linear, and I'm going to compare between linear and angular. The linear displacement delta x equals delta theta, the angular displacement, times r. The linear velocity v equals the angular velocity omega times r. The linear acceleration a equals the angular acceleration alpha times r. If the object is moving in a straight line with no acceleration, so its displacement will be v times delta t. Also, if the object is rotating with no angular acceleration, so its angular displacement can be determined by multiplying omega times delta t. You see, delta x, delta theta, v, omega. So between linear and angular, we have the same equations. But what if the object is moving with an acceleration? So in this case, let's remember the linear equations. We talk for an object that's moving with constant acceleration in a straight line. So v final equals v initial plus at delta x equals v initial delta t plus half a delta t squared, v final squared equals v initial squared plus 2a delta x. We'll do the same here in angular. So instead of v final, I will put omega final equals omega initial plus alpha times delta t. Delta theta instead of delta x equals omega initial delta t plus half alpha delta t squared, and omega final squared equals omega initial squared plus 2 alpha delta theta. The last equation is when you have the initial velocity and you have final velocity, but you don't have the acceleration and looking for the displacement. So delta x in this case equals v final plus v initial divided by 2 all times t. So instead of delta x, I will put delta theta equals omega final plus omega initial divided by 2 times delta t. And these are the equations we are going to use to solve the problems in the next video. Thank you.